when I start my workshops or sequence of lectures, very often I start with underlying that understanding the problem is really the key component of any problem-solving activity. If you don't understand the problem you try to solve, whatever you do, it is usually wasted time. And when I have young people in front of me, some freshmen at some university, my favorite starting puzzle is the following. A farmer has 20 pigs, 40 cows, and 60 horses. And the question is, how many horses does he have if he calls the cows horses? When I had last semester 400 freshman engineering students in the room, you would be amazed at the number of different answers I got from my crowd. And actually the solution is really straightforward. Note that the question is about having courses, and the business of calling one animal by some different name has nothing to do with the question you ask. The correct answer is the farmer still has 60 horses. The question was very precise, and this is the precise answer. Whether it's calling cats or cows or this and that, it is irrelevant, but some people are influenced by that. This is silly example, but then usually I follow by little bit more meaningful example, which is the following. You as engineers, most of you would know it by heart, but still I would like to display it. You have two cities, A and B, and you are traveling between these cities. You are in the car. You are going from one city to another with constant speed of 40 kilometers an hour, constant speed from A to B. The moment you arrive at city B, you return immediately with higher speed of 60 kilometers an hour. And innocent question is, what was your average speed for the whole trip? And again, my experience working with young people is that the crowd of 400 freshmen would shout 50. This is irresistible. If you have two numbers, 40 and 60, and the question includes the term average, you can't resist, but you answer 50. Which, of course, it is not the case. And again, the issue is very much the same. Here, the question is about average speed. And before we do anything, we have to understand the problem. In this case, we have to understand the question, what is average speed? There is really one definition of the average speed. The average speed is really the ratio of the total distance you drove by the total time. If you drove 273 kilometers and it took you 5 hours and 20 minutes, you follow with appropriate division and you determine the average speed. So let's say if the distance between these two cities was, to make calculations easy, 120 kilometers, then you are driving 40 kilometers an hour. It would take you 3 hours to get from A to B. You are returning with 60 kilometers an hour, so it would take 2 hours for your return trip. The whole return trip is 120 plus 120, 240 kilometers. You cover these 240 kilometers in 5 hours, and then you arrive at the answer 48. To illustrate this point, I would like to display a single piece of simulation software at this stage, which is very much the same with slight difference. You have 2 points, A and B. You have boat on the river. Speed of the boat is 50 kilometers an hour, and the current speed is 10 kilometers an hour. So actually, when the boat moves from A to B, going with the current, the speed would be 60. Going the other way, it would be only 40. And of course, we can simulate the whole process. We can see what is happening with average speed, which is staying constant, 60 kilometers an hour, and what is happening to average speed on the way back. And the simple simulation would give you the result you expect, 48 kilometers an hour. But then you can experiment a little bit further. You can set, let's say, river options, and you can say what would happen if the speed of the current, for example, is 24 kilometers an hour and the boat is only 26 kilometers an hour. If you set these options, note that in one direction the boat would be moving 50 kilometers an hour and on return trip would be just 2 kilometers an hour. And this is much more meaningful example, 50 going one way, 2 going the other way. What is the average? Again, temptation of 50 plus 2 divided by 2, getting some 26 result. Only when you simulate this run, and this is very educational simulation for students, one way we are getting constant speed of 50, but then we can see immediately what is happening on the return trip. How painful is it to get back? It takes much longer time, and you can see what is happening to average speed when the boat arrives back at point A. The average speed for the whole trip would be below 4 kilometers an hour. So in a sense, the average of two numbers, 50 and 2, is a little bit below 4. After training like that, the students are very clever. They claim they understand the problem. They would never make mistake like that. Then usually I follow by additional example, and I would like to ask you this very question. Let me change the problem just a little bit. You have again cities A and B, and you go from A to B with the constant speed of 40 kilometers an hour. What speed you should return from B to A to claim 80 kilometers an hour as the average speed for the whole trip? Usually at this point my audience is much smarter. They know that 120 is big no answer. 40 plus 120 divided by 2 to get 80, this is wrong. Clearly you have to go much faster than 120, but how much faster? 200, 300? If you return 500 kilometers an hour, would you get there? Few people are really uncertain about that. Let me follow with the following reasoning. Let's assume that the distance between cities A and B is 40 kilometers. Then you are driving 40 kilometers an hour from A to B. It took you 1 hour to get from A to B. And the distance, the total distance for the return trip is 80 kilometers. To claim 80 kilometers an hour for the whole trip, you have to complete the whole trip in 1 hour, but you already used the first hour of going from A to B. What is the conclusion? If you return with speed of light, you wouldn't make it. You would be 79.999, which is again a little bit counterintuitive, and many students or young people, they have difficulties in understanding this concept. There are some limits to things you can do. So at this stage, very often I introduce rule number 1 of any problem-solving activity. Be sure you understand the problem, basic terms and expressions which are used to define it.